So here's another problem. Give this one a try on your own, then press play when you're ready to see the answer. All right, so example 4, we have x squared plus 8x plus 20 is less than 5. First thing I'm going to do is bring that 5 over to give me x squared plus 8x plus 15. And then I'm going to turn it into just a normal equation, so equals 0. I'm going to factor this to solve for x, and that would be x plus 5 and x plus 3. So that tells me my two critical points are -5 and -3. Drawing me a number line, and I'm just going to draw the number line and label it to ensure that I have values of -5 and -3 on here. From here, my inequality sign in the beginning says strictly less than, which means I'm going to have an open circle when I graph these critical points of -5 and -3. So graphing -5 and -3, that means my answers are only going to be in between -5 and -3 or outside of -5 and -3. So I need to pick a number to test. My favorite number to test, as long as it's not one of my critical points, is 0 because it's the easiest one to plug in. So I'm going to test x equals 0 by plugging it in to the original inequality. I end up with 20 is less than 5. Well, is 20 less than 5? Definitely not. So we would say this is false, which means 0, which was outside of our two critical points, is not a solution, and so our solutions only live inside the 2 points. So that means x must be greater than -5 and x must be less than -3. And I say strictly less than again because that's how my original inequality sign was written. It did not have the or equal to bar underneath it. All right, so that's going to conclude our solving quadratic inequalities with 2 variables through graphing and 1 variable through using algebra and some number lines. All right, I hope you have a great day.